Okay, so in this chapter, it's the chapter name atoms and nuclei. Okay, atoms and nuclei. So this chapter is atom. After that, we will discuss nuclei, nucleus. Yeah. So in this chapter, uh, first thing is the alpha scattering experiment done by Rutherford and two other scientists were also there. So first we will discuss the alpha particle scattering experiment. So first of all, we should know what is alpha particle. So basically, alpha particle is helium nucleus. Helium nucleus means in helium there are two electron, two proton, and two neutrons. If you will remove two electrons from the helium, you will get this helium and two positive charge. Helium ion you will get, and this is known as helium nucleus. So this I have taken from the NCERT. This is given in the NCERT, this diagram. So basically, if you will see, means this experiment means exactly it will look like this. Okay, this is the three-dimensional view. Just wait. See, this is the experimental setup in lab. Here is the sources of alpha particle. Here is the sources of alpha particle beam, which will give alpha particle, which will emit alpha particles. And what are alpha particles? Helium nucleus, helium plus two ion. And this is a circular screen. This is a circular screen. This is a circular fluorescent screen. Fluorescent is circular fluorescent screen, and this is made up of zinc sulfide. Zinc sulfide screen. So what is the use of this fluorescent screen? When the alpha particle will strike with this screen, there will be some flash of light. There will be some flash of light. When the alpha particle will strike with the screen, there will be flash of light due to this fluorescent screen. And this is a gold foil. This gold foil is very thin. Okay, this gold foil, basically this is an experimental setup I am telling. So this is a gold foil. Now from the source, a beam of alpha particle is striking or passing through, means is striking on the, this is a gold foil and this is a beam of alpha particle. There is a collision between two. So after that what happened? Most of the alpha particle in this experiment passed straight. I will tell you the reason also why this happened. Some of the alpha particle are deflected more than 90-degree angle. Some of the alpha particle deflected uh, more than 1 degree angle. Okay, and one alpha particle out of 10 to the power 6 alpha particles is uh, reflected back with an angle of, or you can say uh, deflected with an angle of 180-degree. So basically I am removing now this. Okay, this is a setup. So for this setup we have shown in this way. So basically this is a source of alpha particle here. So don't get confused. Okay, this is the diagram in NCERT. In exam, if they will ask alpha scattering experiment, so you will draw this diagram. So basically what is this? This is a here is vacuum. Around this experimental setup, vacuum is there. means though no particles are there. This is the source of alpha particle. These are lead bricks. These are lead bricks. And what is the use of the lead bricks? You will get the collimated beam of alpha particle. So what will happen from this source? The alpha particle will travel like this. This is the beam of alpha particle, and this is a thin gold foil. Okay, this is a gold foil, thin gold foil. You can see gold foil target about 10 to the power minus 8 meter thick. This is basically very thin gold foil. So alpha particles are striking on this beam. After striking on this beam, most of the alpha particle pass straight through. After striking on this sheet, sorry, this is a gold foil or gold sheet, you can say. So most of the alpha particle passes straight, okay, passes through this gold foil. Hello, Nawal. Hello, Nawal.
Hello, sir.
Nawal, when your practical exams will be conducted?
Sir, they're going on right.
Going on. Okay. Okay. So we are doing the alpha scattering experiment. So in the alpha scattering experiment, this is the source of alpha particle. Means the alpha particles are emitted by this source, and these are lead bricks. So these lead bricks will give the collimated, means undeflected beam of alpha particles. So basically the source of alpha particle, and alpha particles are from the source, alpha particles are emitted, and the beam of the alpha particle then striking on the gold foil. This is a gold foil. Okay, this is a gold foil. This. So most of the alpha particle pass straight. So most pass through. Okay, most of the alpha particle pass straight, and some of the alpha particles are deflected through some angle. Okay, this is the alpha particle after striking with the gold atom of the gold foil. The alpha particle, some of the alpha particle is striking like means deflected to some angle theta. And you can see here some of the alpha particle means 1 in 8,000 is reflected back. Okay, 1 in 8,000 is reflected back. You can see here. And some are deviated through large angle theta. Some are deflected through large angle theta. And this is what? This is a screen. Zinc sulfide screen, fluorescent screen. When the alpha particle will strike on this screen, the flash of light will be there. Flashes of light will be there. And what is this? This is a detector, microscope detector. This will detect the collision of alpha particle with the screen. So basically, this is an experimental setup. What is the main thing in this experiment? Alpha particle are striking on the gold foil. This is the gold foil, and alpha particles are striking. So after striking, some alpha particles are passing straight, penetrating this, passing straight, and some of the alpha particles are deflected in with different angles. This is the conclusion. Okay. So after doing this experiment, there are some conclusions. Okay, so I am removing this diagram. No need of this diagram. Now we will see the conclusion. Basically, this is the graph drawn. This is a graph drawn by the scientist. You can say this is a graph between the number of the scattered particle detected divided by the scattering angle theta. So you can see here, this is the angle. These are the number of particles scattered. Now you can see this angle means the angle which is very close to 0 degree, means most of the particles pass straight. You can see 10 to the power approximately we can say 10 to the power 7 alpha particles, 10 to the power 7, more than 1 million, 10 to the power 7 alpha particle passed straight. You can pass straight because this angle, you can see here with respect to this, the angle is nearly 0. So you can say most of the alpha particle pass straight or remain undeflected, or you can say deflected with very small angle. Now come to this side. At least means you can say very less alpha particle. From this point you can say very less alpha particles are deflected through an angle between 160 to 180. Okay, so this graph will be like this. Okay, now what is alpha particle? If you will remove 2 electrons from helium, you will get helium nucleus, and that is alpha particle. So helium nucleus have 2 proton, 2 neutron, charge on the alpha particle 2e, and mass of the alpha particle is 4 AMU. AMU is atomic mass unit. Okay, so this is given. This is the approx formula. Okay, approximately number of alpha particle deviated at angle theta is given by this, and is the number of alpha particles deviated through some angle theta. K is constant, Z is the atomic number of the foil, sine to the power 4, theta divided by 2. Theta is the deflected angle and is the number of alpha particles deflected. Now this is important. Rutherford's nuclear model of atom. So basically this is the experiment done by the Rutherford, and 2 other scientists were also there. Basically experiment, you can read here, experimental data points shown by dots on a scattering of alpha particles by a thin foil at different angles obtained by Jaeger and Pvt using the setup shown in figure. So basically these are the 2 scientists that has plotted this graph. Okay, and in 12.2 Rutherford nuclear model predicts the solid curve which is seen to be in good agreement with the experiment. Basically 3 scientists have done this experiment. One is Rutherford, other is Jaeger, and other is Marsden. Okay, basically these 2 were the students of the Rutherford. Okay, so we are not going in that. So what is the conclusion of this experiment? We will see that 99, they have observed that, okay, they have observed that 99% of the alpha particles passes undeviated, means 99% of the alpha particle pass straight or passes through the coil straight. So what is the meaning of that? If 99% of the alpha particles are passes straight, means inside atom most of the space is empty, because most of the alpha particle pass straight from the atom of gold. Okay, so you can say most of the space in the atom is free space. So what is the reason of this? Most part of atom is empty. Now second observation, this was the first observation. Second observation, 0.14% of the alpha particle deflected by more than 1 degree angle. So there are some alpha particles that are deflected by more than 1 degree angle. When the deflection will take place, when the alpha particle will strike with something inside the atom, if the alpha particle will strike with something, then there will be deflection. Means inside the atom there is something. So what is the reason of this statement? There is some positive charge inside the atom in very small space. So if the alpha particles are getting deflected, alpha particles are also positively charged, and if the alpha particles are deflected through some angle, Means this is a gold foil and alpha particles are deflected through some angle like this. Okay. So means there will be a repulsion between the alpha particle and something inside the atom. And repulsion will be when there will be the positive charge inside the nucleus. So there is some positive charge inside atom in very small space. That is why some of the alpha particles is deflected by more than 1 degree. The reason of this is this. Another 1 in 10 to the power 6. 10 to the power 6 means 1 million. 1 in 10 to the power 6 alpha particle deviated by 180 degree. What is the meaning of the 180 degree? Suppose this alpha particle is going like this. This is strike with the means this is the collided with the coil and deflected back on the same path, approximately on the same path. So what is the reason of this? You can say the positive charge inside the atom is concentrated to an extremely small space called nucleus. Means there must be a concentrated positive charge. Concentrated positive charge means in very small space there is large positive charge. Concentrated positive charge. If the alpha particle will strike on that concentrated positive charge, then it will be deflected back. And what is that? What is that concentrated positive charge? Nucleus. Now approx size of the nucleus is 10 to the power minus 15 meter, and approx size of the atom is 10 to the power minus 10 meter. Okay, so nucleus is much smaller than the atom. Another, the number of the alpha particle is scattered at a particular angle is different for different metals. Now you can see with the help of this formula, n is equal to kz square sine to the power 4 theta by 2. What is z here? Z is the atomic number. So for different elements or different metals, Z will change, means N will change. What is N? N is the number of alpha particle scattered some angle theta. Means so you can say the number of alpha particle is scattered at a particular angle theta is different for different metals. Okay, and this is happening because of this. Z will change, so N will change. For different value of Z, there will be different values of N also. So you can say different metals have different positive charge in their nucleus. Okay. Now another point, the electrons are attracted by positive nucleus, but electron don't move towards the nucleus. There is one more conclusion from this experiment. The electrons are attracted by the nucleus. The electrons are attracted by positive nucleus, but electron don't move towards nucleus. So what is the reason of that? Because the electrons revolve in circular orbit. This electron is attracted by the nucleus because this electron is negatively charged and this nucleus is positively charged. So there will be the force, electrostatic force of attraction. But this electron is not moving towards the nucleus. This electron is not moving towards the nucleus. But this electron is experiencing some electric force. This electron is experiencing some force and this is not moving towards the nucleus. It means that this electron should move in a circular path. Okay, so this electron should move in a circular path. So this is the electron. So on this electron, this is the force of electrostatic force of attraction. So basically, this electrostatic force of attraction will be equal to the centripetal force for the rotation for the electron to move in a circular path. Okay. So these are the conclusions from the Rutherford's nuclear model of atom. You can take the screenshot. Completed, Matthew? Nabal?
Yes, sir.
Okay. So actually now what is happening? Alpha particles, gold foil, most of the alpha particle passes through the gold foil straight. Some of the alpha particles deflected. Okay. Data is given here. Okay. I have written here. So you can go through it. Right. Take the screenshot. They have plotted the graph like this. This is given in NCERT.
Done.
Okay. So you will get this formula. Okay. Take the screenshot of this formula also. So approximately this formula is given. Before that, there was one more scientist, J.J. Thomson, and the other four was the student of J.J. Thomson. So J.J. Thomson has given the atomic model differently. Plum pudding model. Scroll down. Okay, completed now? Okay. So these conclusions are very, very important. I have written this is the observation. Okay, they have observed this through experiment, and here is the reason why this happened. Take the screenshot.
Yes, sir.
Okay.
Done, sir.
Okay. Just a minute. Actually, Fe is the electrostatic force. Wait. Okay. So basically, this is the because the electron is negatively charged, nucleus is positively charged. So if there are two charges, one is negative, one is positive, so there will be the force of attraction, electrostatic force of attraction, and this electrostatic force of attraction is equal to the centripetal force. Centripetal force. And what is the centripetal force? Centripetal force is the force required by the body to move in a circular path. Centripetal force is a force, the 11th class, in 11th class, circular motion. So centripetal force is a force required by the body to move in a circular path. If anything is moving in a circular path, means centripetal force is must. So what happens? This electric force or electrostatic force is used by the electron, okay, used by the electron as centripetal force, okay, to move in a circular path. So you can write here electron utilizes centripetal force as centripetal force. Electron utilizes electric force or electrostatic force. This is electrostatic force. Utilizes electrostatic force. Electrostatic force as centripetal force and revolve in a circular path. Revolve in a circular path. So if something is revolving in a circular path, that body, actually what is happening here? See, one more thing I want to tell you. At this point, the direction of the velocity is this for the electron. If electron will be here, the direction of the velocity will be this. Because electron is moving in a circular path. In circular path at different points, there will be different direction of the velocity. So direction of the velocity is changing means the velocity is changing means there should be the acceleration. So the acceleration that comes due to the change in the direction of the body in the circular motion is known as the centripetal acceleration. Means this electron is having a centripetal acceleration. I do not know whether you are getting or not, but basically in 11th class, uh, you have done a chapter circular motion. So I think now you do not remember, I think. So centripetal force, I told you what is centripetal force. The force required by the body to move in a circular path, and that centripetal force is provided by some external force. In case of the electron revolving around the nucleus, Centripetal force is provided by this electric force. And if a body is moving in a circular path and due to the change in velocity, direction of the velocity, there is an acceleration of the body, that is centripetal acceleration. So you can say electron have centripetal acceleration. Electron have centripetal acceleration. So for the electron motion, when the electron will be here, direction of the velocity will be this. When electron will be here, direction of the velocity will be this. Means for the electron motion in a circular path, the direction of the velocity is changing. And due to change in the direction of the velocity, there will be one acceleration, that is centripetal acceleration. Okay, now you can take this in short. Just a minute. Okay, now you can take this in short.
Done, sir.
Okay. After this, we will discuss distance of closest approach. So what the distance of the closest approach means, this is the source of the alpha particle. Okay, this is the source of alpha particle, and alpha particle is emitted by this source. So alpha particle is moving. This alpha particle is having some kinetic energy initially. So moving, and alpha particle is having a positive charge, and this nucleus is also having a positive charge. So both will repel. Both will repel. So suppose finally the alpha particle is here at this distance, and at this distance the speed of the alpha particle becomes zero, or you can say the kinetic energy of the alpha particle becomes zero, because initially the alpha particle will have the kinetic energy. Okay, but this alpha particle is positively charged and this nucleus is also positively charged, so both will repel. So there will be the force of repulsion on the alpha particle. So alpha particle will have to do some extra work, and that work will be at the expense of the kinetic energy of the alpha particle. So basically kinetic energy will decrease when the alpha particle will move here. Finally there is a point where the kinetic energy becomes zero, and velocity or speed of the particle, alpha particle, will become zero, and the distance between the alpha particle and the nucleus at that time will be known as the distance of the closest approach, that is r suffix naught. So here we will apply the conservation of mechanical energy. Conservation of mechanical energy we will apply. So applying conservation of mechanical energy. Mechanical energy. So conservation of mechanical energy, you know, means initial potential energy plus initial kinetic energy is equal to final potential energy plus final kinetic energy. Now this is alpha particle, this is okay, one more thing, this is alpha particle and this is the nucleus, positively charged nucleus. So charge on the alpha particle is 2 times of charge on electron, and charge on the nucleus will be atomic number of the nucleus E. Okay, charge on the alpha particle will be Z, charge on the nucleus will be Ze. Okay, Z will be the atomic number. Atomic number is what? Number of proton or number of electrons. Okay, okay, so initial potential energy. Now in electrostatics, if there are two charges, so the potential energy of those two charges will be, now this distance will be taken as infinite distance. This distance will be taken as infinite distance. Okay, Why this distance will be taken as infinite distance? Because this distance is very, very, very small as compared to this distance. This distance will be in 10 to the power minus 15. So as compared to this distance will be some centimeters also. So centimeter as compared to the Fermi or 10 to the power minus 15 is infinite. Okay, so initial potential energy of the system Q1, Q2. Suppose this is Q1 and this is Q2. Q1, Q2, K Q1, Q2 divided by R plus kinetic energy initial. Okay, this is kinetic energy initially. Ke. I am representing the initial kinetic energy with Ke. Final potential energy. Final potential energy will be this. Finally, this is the system. Finally, the alpha particle is here, nucleus is here, and distance between these two is R naught. So it will be K Q1 Q2 divided by R naught, and this distance will be infinite. Okay, you can take this distance as infinite. Plus, finally, the alpha particle will be at rest. So final kinetic energy is 0, and 1 by infinity is 0. I told you that. So this value will become 0. So you will have kinetic energy is equal to K. Now K is 1 upon 4 pi epsilon naught multiplied by Q1 is 2E multiplied by Q2 is ZE divided by R naught. So from here we can calculate R naught. So R naught we will get 2ZE square divided by 4 pi epsilon naught into kinetic energy of the alpha particle. This is very easy. You can multiply this with this, so it will become 4 pi epsilon naught kinetic energy, and you will divide this with this. Okay, so you will get R naught. So this formula you will have. R naught is the distance of closest approach. How much close the alpha particle is to the nucleus. What is E? E is the charge on electron. Z is the atomic number. Z atomic number. What is E? Charge on electron. Ke is the kinetic energy. K is the kinetic energy. And epsilon naught is absolute permittivity. Now you can see here this distance of closest approach is inversely proportional to the kinetic energy. Means more will be the kinetic energy, less will be the distance of closest approach. Or you can say more will be the kinetic energy, less will be the distance of closest approach. Or you can say, okay, it's fine. So the thing I have written here, this is taken from the NCERT. Okay, so when the kinetic energy is maximum, when the kinetic energy is maximum, R naught will be minimum. From this formula you can see. So naturally the maximum kinetic energy of alpha particle will be 7.7 mega electron volt. So this can be calculated. Okay, this can be calculated. For the gold nucleus, this can be calculated. For the gold atom. So for gold, Z is equal to 79. And when you will calculate R naught, you will get this 30 into 10 to the power minus 15 meter, and that is approximately equal to 10 to the power 15. I told you Fermi, FM, and 1 Fermi is equal to 10 to the power minus 15 meter. 1 Fermi is equal to 10 to the power minus 15 meter. Okay, you can calculate R naught from here. To Z, put the value of Z 79. E is 1.6 into 10 to the power minus 19. 4 pi epsilon 1 upon 4 pi epsilon is 9 into 10 to the power 9. Put the value of kinetic energy this. You will get R naught as 30 into 10 to the power minus 15. One more thing, actual size of nucleus is equal to 6 Fermi. 6 Fermi means 6 into 10 to the power minus 15 meter. Conservation of mechanical energy. Initial kinetic energy plus final initial potential energy plus initial kinetic energy is equal to final potential energy plus final kinetic energy. Potential energy of system of two charges. What is the formula for the potential energy for a system of two charges separated by a distance r? Suppose this charge is q1, this charge is q1, this charge is q2, separated by a distance r. The potential energy of two charges u will be given by k q1 q2 divided by r. In electrostatics we did this, and this distance, why I have taken infinite? Because as compared to this distance is very large. That is why this distance you will take infinite. And initially the potential energy will be like this. Alpha particle is here and nucleus is here. Both are at a distance, infinite distance. So k q1 q2 divided by infinite will be 0. And initially there will be some kinetic energy of the alpha particle, because initially alpha particle is rest and finally you are giving some kinetic energy to alpha particle. That is why the alpha particle is moving. But there is a kinetic energy the alpha particle have, but here due to the alpha particle is also positively charged and nucleus is also positively charged. So this, due to this nucleus, there will be force of repulsion, means in this direction. In this direction there will be the force. Alpha particle is moving in this direction, but due to the repulsion there will be the force of repulsion in this direction on the alpha particle. So kinetic energy of the alpha particle will reduce due to that, and finally there will be a point where the kinetic energy of the alpha particle will become 0. And at that time and at that moment, the distance between the alpha particle and the nucleus is distance of closest approach. Okay, take the screenshot. In the next class, we will finish this chapter. Okay, this question will solve alpha particles of kinetic energy 5 mega electron volt are projected towards the uranium nucleus, and Z is equal to 92. Find the order of distance of the closest approach. Simply you have to apply this formula. What is the formula of the distance of the closest approach? R0 is equal to 2Z E square 4 pi epsilon naught into kinetic energy of the alpha particle. So what is given? Kinetic energy of the alpha particle is given. You can see kinetic energy of the alpha particle is 5 mega electron volt. 5 mega electron volt. Okay, and atomic number Z is given 92. R0 we have to find. So R0 we can find very easily. This is 1 upon 4 pi epsilon naught. So 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. So put this value 9 into 10 to the power 9. After that this is 2. So multiply it with 2. After that this is Z. What is the value of Z? 92. After that E square. E is 1.6 into 10 to the power minus 19. And square of this divided by kinetic energy. Kinetic energy is 5 mega electron volt. 1 mega electron volt. Actually, what we should do now? 1 mega electron volt is equal to 10 to the power 6 electron volt, and 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Okay, so basically you can convert this 5 mega electron volt. So 5 into 10 to the power 6 into 1.6 into 10 to the power minus 19. So this is square with cancel with this. So R0 you will get 640 into 10 to the power minus 16, and you can write this as 10 to the power 3. This 640 can be written as approximately 10 to the power 3 multiplied by 10 to the power minus 16. So approximately you will get the answer 10 to the power minus 13 meter. Okay, take the screenshot. So this formula you will use and you will get the answer, but you have to do the calculation at the same time. Completed. Matthew completed. Nawal completed.
Yes.
Okay. After this, the topic is impact parameter. So impact parameter is represented by small b. We will represent impact parameter with small b. And this is also measured in Fermi because this is very small distance. So now what is impact parameter? Suppose this is the nucleus and this is the alpha particle. And this alpha particle is moving like this. So this is the path of the motion of the alpha particle. So alpha particle is moving like this. Because alpha particle is also a positive charge and nucleus is also positively charged, and when it will go like this, when it will come somewhere here or here, so there will be a force of repulsion. So due to the force of repulsion, the path of the alpha particle is like this, and this initial distance is known as the impact parameter. So what is impact parameter? It is the perpendicular distance of initial velocity. So initially there will be some velocity here. This is means this is the initial velocity. Here will be the initial velocity. So it is the perpendicular distance of initial velocity vector of alpha particle with the center of nucleus. Okay, so basically perpendicular distance. So this is the center of the nucleus. This is the center of the nucleus. So this distance is known as the impact parameter. So if impact parameter becomes zero, impact parameter will become zero, means the alpha particle will go like this and strike on the center of the atom, center of the nucleus, center of the atom, that is nucleus. So the alpha particle will strike at the center of the nucleus. Means alpha particle if striking on the nucleus, then what will happen? It will deflected by 180 degree. So theta, what is theta? Theta is the angle of deflection. So angle of deflection will be pi. Pi is 180 degree. So what is theta? Theta is the angle of deflection. Okay. Now if suppose B is much greater than R naught, this is R naught. This distance is R naught. If the alpha particle will be here, okay, then this perpendicular distance will be the distance of closest approach. R naught is distance of closest approach. So if this B becomes much larger, then in that case the alpha particle will move like this. Here will be nucleus and alpha particle will move like this. So in that case, what will happen? Uh, theta will become 0 degree. Okay, theta will be approximately equal to theta 0 degree, means alpha particle will pass straight. Why the alpha particle will pass straight? Because the alpha particle will now will not strike with the nucleus, and if it is not striking with the nucleus, so inside the atom most of the space is empty and alpha particle will pass straight. Okay, take the screenshot.
Done.
Okay. After that, basically what we have done basically Rutherford model of, we were studying what? Rutherford model of atom. Okay.
Yes.
So this was the Rutherford model of atom, and here these are the conclusions. So see this conclusion: the electrons are attracted by the positive nucleus, but electron don't move toward the nucleus. This is right, because electrostatic force is utilized as the centripetal force to move in a circular path. Now we will discuss the drawbacks. So there was a scientist, we also know that Maxwell equations, now we have studied in electromagnetic wave. So there was a scientist Maxwell said that after actually Rutherford done the experiment before, but after the Maxwell came, other scientists came, so they give this. Okay. So Maxwell said an accelerated charged particle emits radiation or energy. If there is a charged particle, in electromagnetic wave, I told you that if there is a charged particle and charged particle is accelerating, then there are the electromagnetic waves. Electromagnetic waves have the energy, so the charged particle will emit energy if a charged particle is accelerating. Now, this is the model of the atom given by the Rutherford. So this is the electron. And what is electron? Electron is a charged particle. An electron is moving in a circular path, so electron is having an acceleration also. So if the electron is a charged particle and the electron is having the acceleration also, means it will also emit radiation. Okay. It will also emit radiation. So if it will emit radiation means if it will emit energy, if it will emit energy means the electron energy, when the electron is revolving, an electron is a charged particle, accelerated charged particle. So what the Maxwell said, an accelerated charged particle will emit energy. So means electron is also revolving, electron is also a charged particle, electron is also having a acceleration, centripetal acceleration. So electron will also emit some energy. So if electron gives some energy, so energy of the electron will decrease, and due to that, if the energy of the electron will decrease, the electron will be attracted by the nucleus like this. So the motion of the electron will be like this. So finally, after some time, it will collide with the nucleus. So electron losing energy due to the energy, because according to the Maxwell, the electron will lose the energy. If the electron will lose the energy, then radius of the orbit will become less because the nucleus is attracting the electron. So what will happen? Finally, the electron will fall into the nucleus. And if in an atom, electron fall into the nucleus, then atom will destroy. Means we all will destroy. We are also made up of atom now, but we are here. It means this theory is not correct, given by the Rutherford. So according to this, what will happen? Electron will fall into nucleus or collide with nucleus. Electron will. So you can see here, electron continuously emits radiation or energy. Okay. So and electron will collide. Finally, the electron will collide with nucleus. And they have calculated the time also. In 10 to the power 8 second, it will fall into the nucleus or collide with the nucleus. This will happen in 10 to the power minus 8 second. Minus 8 second. Hence, atom will not stable. If the electron will collide with the nucleus, then atom will be destroyed, or you can say atom will not be stable. And if atom is not stable, means everything is made up of atom. Means everything will not be stable. That is not true. So basically, this is the drawback of the Rutherford model of atom. According to the Rutherford, the electron can revolve in any of the orbit. Now, second, it cannot explain the discrete spectrum of atom. what the Rutherford said, electron can revolve in any circular orbit, and if electron is revolving in any of the circular orbit, due to that there will be the continuous spectrum, and these things na, we will discuss in the next class, the spectrum, absorption spectrum and all that we will discuss in the next class. Okay, so this was the second drawback. If electron is revolving in all the orbits according to the Rutherford, so it will have, it should have a continuous spectrum, but some atoms have the, many of the atoms have the discrete spectrum. I will explain in the next class this, okay, because this point will come in the next class. So these are the drawbacks of the Rutherford model of atom. Take the screenshot.
Done.
Okay. Okay, after this now, we will discuss the minute. Bohr's atomic matter model. Just wait. After this, after there are some drawbacks now in the Rutherford model of atom. So after that, in 1903, 1913, there was a scientist Bohr, Neil Bohr. So he gave his model of atom. Means actually what he has done, na? He had done means some modifications in the Rutherford's model of atom. So Bohr's atomic model. So first point in the Bohr's atomic model is, so in 1913, Bohr gave his atomic model with some modifications, with some modifications in Rutherford model. So first point in this, electron revolves only in certain stable orbit. These orbits have fixed energy and these are called energy levels or stationary state. Electron can revolve only in certain Only in certain stable orbits. These orbits have fixed energy these orbits have fixed energy and these are called energy levels. These are called energy levels or stationary state. Stationary state. So what is the meaning of this? And these were named as KLMN. One more thing. And these were named as these were named as KLMN. Okay. These are known as KLMN are known as the energy level. Okay. So how these energy levels are? Suppose this is the nucleus. So around the nucleus, the energy levels are like this. First energy level, second energy level. So should be concentric circle. This is K energy level. This is L. This is M. Energy of K energy level is minus 13.6. Suppose I write here minus of 13.6 electron volt. For L energy level, the energy is 3 - 3.4 electron volt. For M energy level, the energy is minus 1.5 electron volt. This thing we will discuss in detail. And after that, there is KLMN shell that will have more energy. So what the Bohr said that the electron can revolve in a fixed orbit, having a fixed energy. Okay.
Okay, sir.
Yeah. So this is point number one. So point number second of Bohr's model. Suppose this electron is revolving in L. Suppose the electron is revolving in L orbit. So throughout the motion, the energy of the electron will be minus 3.4 electron volt. So second point is that electron have same energy electron have same energy as that of orbit in which it is revolving. Okay. One more thing Bohr said. If suppose the electron is revolving in k orbit, k energy level. So if the electron will revolving in this energy level, it will not radiate, means it will not gain energy or it will not lose energy. Okay. So point number third, while revolving in a particular energy level, level, or you can say energy level, or you can say orbit, electron do not emit any radiation. Very important point. Do not emit any radiation. But here is one problem. What is the problem? I'm telling. What Maxwell said, if the electron is revolving circular in if the electron, if any charge particle having acceleration will radiate energy, but the Bohr said electron, if the electron is revolving in the orbit, means electron is a charged particle and electron is having a acceleration, but the Bohr is saying electron is not emitting energy, not radiating any energy. Now this is a contradiction. Actually, uh, there are two things basically. There are one classical mechanics, another is quantum mechanics. So at the atomic level, na 100% classical mechanics we cannot apply. We have to change our perception. We have to change our thinking. Means here the quantum mechanics will quantum mechanics will work. So you can say that classical electromagnetism and classical mechanics means Newtonian mechanics. Classical mechanics cannot be applied on atomic cannot be 100% applied on atomic level. So if we are working with the atomic level, so 100% we cannot apply the classical mechanics or classical electrodynamics. We have to move to the quantum mechanics. That is different thing. Point number 4. If suppose the electron is absorbing some energy while revolving in energy level, so if the electron will get some energy, so electron will move from k orbit to k energy level to L energy level. If electron is gaining some energy, and suppose if the electron is revolving at L energy level and electron loses some energy, so it will come to the k. Okay, so you can say that if an electron absorbs or emit energy, it must move to different energy level. Okay, means if the suppose electron is here, here is electron, suppose electron gains some energy, so it will move from k energy level to n energy level. So now electron is at n energy level. Now if electron is gaining energy, so it will move from higher energy level, it will move to higher energy level. From k it will go to L. But if suppose the electron is here and electron loses some energy, so on losing energy the electron will move to the lower energy level, it will come to the k. Okay, so write down. Take the screenshot.
In terms of
Nawal,